Consider the expansion of 8x cubed minus 1 over 2x to the power of n, where n belongs to z plus. So that means z plus means it's a positive integer. So determine all possible values of n for which the expansion has non-zero constant term. So we need to find the value of n for which the expansion has a non-zero constant term. The expansion should have a constant term. So now, whenever we talk about a binomial expansion, and if I need to think about finding a constant term, so we should always think about doing it like this. That is, the general term, whenever any binomial term expression is given in the form of a plus b whole power n, the general term of this expansion would be equals to ncr into a to the power of n minus r into b to the power of r. Now, if I use this, and in place of a, we have 8x cubed, and in place of b, we have negative 1 over 2x. And if I use that, so it's going to be ncr. So n is unknown, which I'm going to take it as n itself, and r is also unknown. And in place of a, I'm going to substitute 8x cubed to the power of n minus r, and b to the power of, and in place of b, we have negative 1 over 2x to the power of r. Now, if I simplify this, this is going to be ncr. The power will belongs to both. So ncr times 8 to the power of n minus r into x to the power of 3n minus 3r. And this is going to be negative 1 to the power of r divided by 2 to the power of r into x to the power of r. Now, I can also combine these two. When we combine these two, and the remaining terms, I'm going to keep it as it is. So it's going to be ncr into a to the power of n minus r. And I can also write this one at the front. So it's negative 1 to the power of r divided by 2 to the power of r. And this looks like x to a to the power of m over a to the power of n, which can be written as a to the power of m minus n. So that's why this is going to be x to the power of 3n minus 3r minus r. And this has to be equals to ncr into 8 to the power of n minus r and negative 1 to the power of r over 2 to the power of r into, I'll be getting the general term to be, so if I simplify this, I'll be getting 3n minus 4. So when I say this has a constant term, this expansion has a constant term, so that means there should be some value of n and r must be there, so that that part should become 0. So constant term means there should not be any x. So I need to have x power 0. So which means your 3n minus 4r should be equals to 0. And here we need to determine all possible values of n. So now, which means if I think about finding a possible values of n, so here n would be equals to, either you can take it as n is equals to 4 divided by 3 times r. Or in another way, you can also say that r is equals to 3 times n divided by 4. Now, the first thing that we have to observe here is, so clearly we know this, here your r cannot be fraction. So r has to be an integer. So when can the r be integer? The r will be integer only when n is a multiple of 4. So if n is a multiple of 4, only then these things would get cancelled out. So that's why n should be, it's either 4 or 8 or 12 or 16, and it goes on. And these are the possible values of n. And here, of course, n must be multiple of 4, only then I'll be able to cancel it. N cannot be 2, n cannot be 5, n cannot be 6, because if I put n as 6 here, so if I simplify it, I'll be getting a fractional answer or a decimal answer, so which is not an integer. So that's why n must be a multiple of 4. So in general, we can also say it as n is 4 times some constant, where k belongs to a positive integer. So we can also say this. And this is the right answer for the sum. This overall carries 5 marks. And the first mark is for writing the general term. And the second mark is for recognizing, of course, all these simplifications. All these simplification is for second mark. And the third mark is for recognizing that we will be getting a constant term when we equate this to 0. So this plays a big role here. So this would carry a third mark. And the fourth mark is for, so you can maybe make R the subject or maybe make N the subject. So one of these two things, this would give us the fourth mark. And the final mark is for finding the final answer. Of course, it's completely fine even leaving it like this. So even if you write it as n equals to 4 plus 8 plus 12 plus 16 and so on, that's also completely fine. This is how the 5 marks are distributed for this sum.